So today we're going to be looking at population sampling. Now, if we look at those two words, population means everything, the entire category. So if we're looking at people, it means all the people. If we're looking at birds, it means all the birds. If we're looking at cars, we're looking at all the cars. Whereas the word sampling means only a small proportion or a small group of the bigger population. So if this is population, then this is the sample. Census. The word census means when we take a survey and we ask everybody or every item or everything. So it's a process of collecting data from every member of the population. Well, what is the word to describe when we're only asking a sample? That word is poll. So when we're only asking a few of the population or a sample of the population, we call that a poll. Now we're going to study the maths behind or the numbers behind this, and we call that statistics. So population statistics and sample statistics. So population statistics is looking at the data collected by the census, and these sample statistics is looking at the numbers collected from the poll. So population statistics is looking at the population, and sample statistics is looking at the sample. Now, it would be more ideal to look at the population to see what people really want or what the things really are. But it can get very, very expensive. And it's a lot cheaper to just look at the smaller sample. So what do? We look at the smaller sample and we use that to predict the population. So let's look at an example where it does that. A large box is filled with 500 building blocks that are of all the same size. The blocks are yellow, red, and blue. We have yellow, red, and blue. A sample of 20 blocks. So this is a population. The sample is 20. Is taken, and it's found that 6 are yellow, 9 are red, and the rest are blue. 6 are yellow, 9 are red, and the rest are blue. So how do we find the blue? We take 20 minus 6 minus 9. 20 minus 6 is 14. 14 minus 9 is 5. So there's 5 blue. Just double check. 6 plus 9 is 15. Plus 5 is 20. So that's how many there are in the sample. So we're good. Let's keep reading. Make an estimate for the number of each color of block in the box. So now that we have the ratio, we can figure out how many are in the real population by giving a good estimate. So we can do this by looking at the fraction or the ratio. So out of the 20, we have, if we want to look at the 500, we have to take the proportion and multiply it appropriately. So if there are more red, then we're going to expect to have more red in the 500. And if there's the least blue, we're going to expect to have the least blue in the 500. So how do we do this? We're going to put 6 over 20, 9 over 20, and 5 over 20. And we're going to use this fraction and multiply it by how many we want. So we multiply each of them by 500. So this fraction, think about this fraction, the 5 out of 20, for example. If it's 5 out of 20 is our proportion and we took a sample of 20, then we would get 5 out of the 20. But now that we multiply it by 500, we're going to figure out how many in the 500. So 6 times 500 over 20, we can easily cancel the 0, and then 50 divided by 2 is 25. So instead of multiplying 500 divided by 20, we're going to multiply by 25. Okay, simplifying those three questions. So now we have 6 times 25, 25, 50, 75, 100, and 125, and 150. So just 150 yellow. 9 times 25 is like 10 times 25, 250. Take away one lot of 25 to make 9 lots of 25s. So that is 225. And then we have 5 times 25. That's the same as saying 10 times 25, which is 250. and then split it in half for the 5 groups of 25. So 250 divided by 2 is 125. And as we predicted, they are mostly red and they are the least amount in the blue color. So our maths is correct. And another way to check that it's right is by adding these three numbers and checking that it is 500. Let's look at another example. A sample of 200 fish is taken from a lake. 200 is our sample. Tagged and then released. So these got tagged and they got released. Sometimes later, another sample of 150 fish is taken and 15 of them have tags. So 15 fish have tags out of 150 that were taken. So now this is a proportion of tags out of the taken, which should give us the same ratio as the 200 tagged, and it will give us the total population down here. So how do we solve this? Well, we'll flip it over. 150 that were taken, 15 were tagged, and so the total population will have the same ratio over the 200 that were tagged. And bringing the 200 over, we have 150 divided by 15 times 200 to give us the total population. Population. Oh, I've been spelling it wrong. Population. You get the point. Anyway, so 150 divided by 15 is 10. 10 times 200. So the total population is 2,000. And what are we talking about? Fish. So this is a summary of the formula that we use. So the total is equal to the total of the wildlife in the second sample over the tagged times how many tagged. As long as you keep your ratios correct, you can manipulate the formula and get to the answer. Let's have a look at another example. State whether or not each of the following survey methods will result in a bias sample. For those that you think are biased, give a reason why. You want to know the favorite sport of a city, and then you go and ask the people at the football match. Now, as you can see, the people at the football match will probably like football. So this is definitely a biased survey, because people who are absent and probably not liking football are not there. People who are absent may like other sports, are not surveyed. Next example, you're trying to find out how much time each day a person spends using a mobile phone. So you question people who are entering a mobile phone shop. Is this biased? This is definitely biased because these people are in the mobile phone shop, so they're probably more likely to be phone users. Let's look at the next sample. You want to survey on the use of parks in your city. So a survey form is sent to all the home and businesses around the city. Do you think this is biased? This is also biased because there are people that don't own a home, non-home owners, or non-business owners that can't answer the survey. And also it's relying on people to return it, which means only certain people will respond to the survey. Next question. You want to know about changes to speed zones in your local area. So you randomly select people from the local area phone book and conduct a phone poll. This is probably also biased, because even though they're randomly selected, people that are not in the phone book will not be selected. Let's look at the next example. A very large business wants to know if its employees would use gym facilities. So we're looking at employees if provided. So every third name on a list of employees is surveyed. So we're looking at the population, not a sample. Like, we're looking at a sample of the population, but we're looking at every third name. So this time it's actually quite fair, because by selecting every third name, a random sample is generated. So everybody has an equal chance to respond. Let's have a look at some other keywords. You need to make sure you understand every red word that you see in this PowerPoint. Judgemental sampling. So this is picking on people that have special knowledge. This is definitely unreliable and biased, because they are not likely to reflect the whole population. It's like asking tennis players how to play tennis and whether tennis is good, and then using that data to represent all sports players. That would not be fair. But picking on special people with special knowledge is very useful, because you get knowledge of specific topics. So if you wanted to understand how to fix electricity around your house, you definitely ask people with who are electricians, for example. So judgmental sampling is only useful if you're trying to find out specific knowledge, but it's not fair, and it's biased, and you can't use this to generalize a bigger population. Convenience sampling. So what does convenience sampling mean? It means you pick random people from a certain location because it's convenient, or you call people, numbers that pop up because it's convenient, or you survey people online. Now this is definitely biased, because it depends on whether people are motivated to answer you or not. So you might get the same kind of people that respond to your surveys, and not random bunch of people. Next example, for each of the following situations, state whether judgmental sampling or convenience sampling has been used, and list some factors that could produce bias. People coming out of a cinema on Wednesday afternoon are asked their opinion about the movie they've just seen. This is a judgmental sampling, because people who have seen the movie are sampled, and they have special knowledge about the movie. It is also convenient sampling, because the same sample is limited to people who happen to be there on a Wednesday afternoon. So the Wednesday makes it convenient, and because people coming out of a cinema, that is also convenient, and because they've watched a movie, they are judgmental. So this is definitely biased. You ask everyone who sits with you at lunch whether they prefer cats or dogs. Who sits with you at lunch? So this is convenience, because of location. Convenience sampling. This is going to give results that are probably biased, because people who sit together are more likely, not always, more likely to be similar to each other, and doesn't represent the whole population. C. All scientists who have qualification in climate studies are asked for their forecast regarding climate change. So this is not talking about convenience, this is talking about qualification, so we're talking about judgmental. So this is judgmental sampling, because people with expertise in climate studies are needed for their special knowledge. The next word we need to understand is random sampling. This is a favorite sampling to predict bigger population. Subjects have equal chance of being chosen, and For example, we can do this by picking names out of a hat for small groups. If it's a larger group, we can assign numbers and then pick the numbers randomly with a random generator. And this is much more accurate because there's less bias. How else can we improve the accuracy? We can improve our data collection by getting bigger groups. The bigger the sample, the better the data. But again, it does get expensive. And how else can you make it more accurate? You could repeat the experiment over and over again. The more you repeat it, the more likely your data is getting closer to the population's data. A die is rolled 60 times, and the result for each outcome is recorded. This experiment is repeated so that 5 sets of results are collected. These results are shown on the table opposite. So what does that mean? So we roll the dice 60 times. Then we write down how many times 1 came out, 2 came out, 3 came out, 4 came out, 5 and 6. And then we do it again, roll it 60 times again, and then again, and again, and then again. So we roll it 60 times, 5 times. Use each set of results separately to decide whether you think the die is fair. So if you're rolling something 60 times and there are 6 choices, then the expected result will be 10. So when we look at the first set, we have 10 for 1, which is great, but 2 came out too many times, so did 3, 4 didn't come out enough, 12 came out too many times, and 6 didn't come out enough. So in other words, it seems very biased from looking at each set. Using the separate decisions you made in the first part, make an overall decision about the fairness of the dice. Oh, hang on. So that means it's biased. That one is biased. That one is biased. That one is biased. That one is also seeming like it's biased. Now, looking at these, if I just looked at what I've said over and over, I would say that it's biased. However, if we look at each number, it's not always low and it's not always high. So it doesn't seem like the pattern is repeating. So it doesn't conclude that it is biased or not biased. But once we're looking at a few together, we can start to see that it is not a pattern that is repeating. So we can't straight away say that it's biased, unlike when we're looking at just one set. Part C, combine the results and comment again about fairness of the die. So combining the results, now if we're going to throw it 5 times, I'm going to expect to get, I'm expecting to get 50 1s, 52s, 53s, 54s, 55s, and 56. Let's add them up and see what we get. 10 plus 10 plus 11 plus 11 plus 7. So 10, 20, 31, 42, 49. The total for number 2 is also 49. The total of 3 is 53. The total of 4 is 54. The total of 5 is 49. And the total of 6 is 46, which is not bad. All these numbers are very close to our expected 50. So all in all, the die seems to be fair. So from this example, I hope you can see that when we look at more results or repeated results, we can get the sense that it is fair. So it gives us a better judgment.